Let us see second problem on BCH decoding. A triple error correct problem is a triple error correcting 15,5 BCH code has received a code word. So this is the received code word with two errors. They have mentioned that it has this received code word has two errors. Although PCH code has the capacity to correct triple errors, but this received code word has two errors. So you have to find the correct code word. So first you have to see what is n. N is equal to 15. That means you have to use Galois field 16. So they will not mention you. Then you have to. They may mention you or not. So you have to use these formulas. This is prerequisite. So you are using n given is n equal to 15. You have to use Galois field 16, which whose elements are generated with mod of primitive polynomial x raised to 4 plus x plus 1. Now how these elements come, that video is available on this channel, you can check that. So different elements in Galois field 16 are obtained as mod of x raised to 4 plus x plus 1, mod of primitive polynomial. Their values are these, like alpha 4 has value alpha plus 1, alpha 13 has value alpha cube plus alpha square plus 1. Whenever Galois field 16 is there, it is compulsory that alpha raised to 15 is equal to 1. If it is Galois field 8, then alpha raised to 7 is equal to 1. Okay, so if they don't mention it, you assume this and by heart this and write in the exam these equations. No need to derive the equations. Okay, so first step is finding syndromes. So if there are two errors to be corrected, the number of syndromes you have to compute is equal to 2TC. So TC is a number of errors in the received code word. So that are equal to 2. So number of syndromes you have to find is equal to 4. Okay, so first we will find syndrome 1, that is S1, that is equal to y of alpha. So y is this one. So y is this one. So here instead of x you have to put alpha. So instead of x here you have to put alpha. Y alpha is S1. Y alpha received a code word y. Instead of x write alpha, that is your S1. So alpha plus alpha 4 plus alpha 5 plus alpha 7 plus alpha 9 plus alpha 12. After that you have to put the values. So alpha is alpha, then alpha 4 is alpha plus 1, then alpha 5 is alpha square plus alpha, alpha 7 is alpha cube plus alpha plus 1. You can see here. Alpha 9 is equal to alpha cube plus alpha, alpha 12 is alpha cube plus alpha square plus alpha plus 1. Now similar terms you have to cancel out. So same I have written again here, because here if I cancelled it out, you might not be understood what is done. So two steps you could combine two steps, like writing the values of alpha 4 of alpha 5 and cancelling out the similar terms. No need to write it again, but for your understanding I have written it again. So if you cancel out similar terms, like alpha is cancelled out with alpha, then 1 is cancelled with 1, likewise. So why we are cancelling out similar terms? Because in binary addition 1 plus 1 or XOR 1 plus 1 is equal to 0, or in XOR operation 1 plus 1 is equal to 0. That's why we are cancelling out similar terms. So S1 you will get it as alpha cube plus 1. Alpha cube plus 1 is nothing but alpha 14. So that is alpha 14. So S1 is alpha 14. S2 is S1 square, that is alpha 14 square. So that is equal to alpha 22. So alpha 22, whenever it goes beyond 15, this power goes beyond 15, you have to express it in terms of power of 15. So alpha 15 into alpha 13 is alpha 22. So alpha 15 is 1. So alpha 13. So S2 is alpha 13. After that, S3. So S3 is y alpha cube. So in the equation of yx, you have to put in the equation of yx, this is yx, na? So you have to put alpha cube instead of x. So alpha cube raised to 4, then alpha cube raised to 5, likewise alpha cube raised to 7, alpha cube raised to 9, alpha cube raised to 12 again. So alpha cube, this is 12, 3 5 15, 3 7 21, 3 9 27, 12 3 36. Again it is okay, 12 is there, 15 is okay, it goes beyond 15, so alpha 15 into alpha 6, it goes beyond 15, so alpha 15 into alpha 12, 36 is alpha 15 into alpha 15 into alpha 6, 30 plus 6, so alpha 15 into alpha 15, that's why. So why alpha 15? Because we can put 1 there, na? So it will simplify the equations. So alpha cube, alpha 12, alpha 15 is 1, here alpha 6, then this is alpha 12, here alpha 6, because alpha 15 1, alpha 15 is 1. So remaining is alpha cube plus 1, so that is equal to alpha 14. Alpha 40, alpha cube plus 1. Okay, after that S4 is S2 square. S2 is alpha 13. S2, 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 where is S2? S2 is alpha 13. So that is equal to alpha 13 square. Alpha 13 square means 26. Means alpha 15 into alpha 11. Alpha 15 is 1, alpha 11. That is equal to alpha 11. Now you have to form the matrix M. So matrix M is S1, S2, S2, S3. S1 is alpha 14, S2 is alpha 13, S2 is alpha 13, S3 is alpha 14. Then you have to obtain the mod. Mod is this and this multiplication plus this and this multiplication. So why plus? Because this is mod 2 operations, where minus is plus 1 is equal to minus 1. That's why. So 14 square plus 13 square. So 14 square, that is 14 into 2, 28. 13 into 2, 26, because powers gets multiplied, na? If it is a power, then it gets multiplied. So 22 is 15 into 13, 26 is 15 into 11, that is alpha 13 in plus alpha 11. Now alpha 13 is equal to, what is alpha 13? Alpha 13 is equal to alpha cube plus alpha square plus 1. So that is written here. And alpha 11 is alpha cube plus alpha square plus alpha cube plus alpha square plus alpha. So remaining is alpha plus 1. Alpha plus 1 is alpha 4. So M inverse, how to find the M inverse? Is equal to 1 by mod M. Mod M is alpha 4. And you have to exchange these. You have to take alpha 14 here and alpha 14 here, then alpha 13 here, alpha 13 here. Here there is no difference because similar terms are there. But if there are different terms, this matrix is, you have to take this here, this here, this here, and this here. So that is this matrix. So you have to divide it with alpha 4. So 14 divided by 4 is 14 minus 4, that is 10. 13 by 4 is 13 minus 4, 9. 14 by 4, 10. So in this way you got the M inverse. So after that, step 3 is find error vector. Error vector is, you have to by heart this equation, lambda 2 lambda 1 is equal to M inverse S3 S4. Lambda 2 lambda 1 is equal to M inverse S3 S4. M inverse, we have seen it as alpha 10, alpha 9, alpha 9, alpha 10. S3 is alpha 14, S4 is alpha 11. S4 is alpha 11, S3 is alpha 14, and M inverse is this one, 10, 9, 9, 10. Again matrix multiplication. So this multiplied by this, alpha 10 into alpha 14 plus alpha 9 into alpha 11, this multiplied by this plus this multiplied by this. So 10 plus 12, 14 is 24, 9 plus 11 is 20, 9 plus 14 is 23, 10 plus 11 is 21. Then again you have to express in terms of 15. So alpha 15 into alpha 9, alpha 15 into alpha 5, alpha 15 into alpha 8, alpha 15 into alpha 6. So alpha 15 is 1, so alpha 9 plus alpha 5, alpha 8 plus alpha 6. So alpha 9 is equal to alpha cube plus alpha, alpha 5 is alpha square plus alpha, alpha 8 is alpha square plus 1, alpha 6 is alpha cube plus alpha square. All these values are here. Like alpha 9 is alpha cube plus alpha. And other things you can see. So after that similar terms gets cancelled out. So alpha cube plus alpha square. Here alpha cube plus 1. So alpha cube plus alpha square is alpha 6. Alpha cube plus 1 is equal to alpha 14. Alpha cube plus 1 is alpha 14. So once you get this alpha 6, alpha 14, so this you are getting for this lambda 2, lambda 1 is equal to alpha 6, alpha 14. That means lambda 1 is equal to alpha 14 and lambda 2 is equal to alpha 6. So you have to write the equation lambda x is equal to 1 plus lambda 1 x, so alpha 14x plus alpha 6x square. So this is step 3. So you got this. So this equation we have solved up to this. So lambda 1 is 14, alpha 14, lambda 2 is alpha 6. So we have to write it in terms of lambda x as 1 plus alpha 14x plus alpha 6x square. After this there is trial and error to find the roots. Now simple trick I will tell you. If well, let us see if you understand this. So trial and error is such a way that you have to find alpha 6 in such a way that there is alpha 6 is a multiplication of two alphas where the powers are added to 6. Alpha 6, first you have to find this alpha raised to 6 in terms of multiplication of two alphas with particular powers, so that their powers gets added to 6. Now this 6 is so first you have to find alpha 6 or this in terms of powers of two alphas, and then their addition will be should be equal to alpha 14. Their addition should be equal to alpha 14. So it is like so you have to find alpha 6 such that it is the multiplication of two alphas, such that this x and y you don't know. This and x plus y should be equal to 6. X plus y is equal to 6, and alpha x plus alpha y equal to alpha 14. So alpha 6 you have to express in alpha x into alpha y. X plus y is equal to 6 and alpha x plus alpha y is equal to alpha 14. So you want two alphas whose additions equal to alpha 14. So you say this alpha 6 is expressed as alpha x into alpha y, where x plus y is equal to 6 and alpha x plus alpha y is equal to alpha 14. So for that you have to observe this table. So whose alpha's additions is equal to alpha 14. So if you see alpha 14 is equal to alpha cube plus 1, alpha cube plus 1. So you can observe here which alpha's addition is equal to alpha cube plus 1. So if you see here alpha cube alpha 10 and 11, alpha cube plus 1 9. Suppose alpha cube हे पण नाही हे alpha cube plus alpha square plus alpha alpha cube cancel होईल, alpha cube हे पण cancel होईल. So alpha cube plus 1 पाहिजे ना. Alpha cube this one 10 and 11. If you add alpha 10 plus alpha 11, then that is equal to alpha cube. This alpha square gets cancelled out with this alpha square, and this alpha gets cancelled out with this alpha, so remaining is alpha cube plus 1. So if you add alpha 10 plus alpha 11, alpha 10 plus alpha 11, then alpha cube is there, then alpha square gets cancelled out, alpha gets cancelled out, so you will get only alpha cube plus 1. So you got that alpha 14 is equal to alpha 10 plus alpha 11. So this you got, that alpha 14 is equal to, so alpha 14 is equal to alpha 10 plus alpha 11. This you got from the table. So after that you have to see whether we have seen alpha 6 is equal to alpha x into alpha y. So you have to see x plus y is equal to 6. You should get x plus y is equal to 6. So you got one thing, that alpha 10 and alpha 11 is equal to alpha 14. So you have to see whether their powers equal to 6. So 10 plus 11 is equal to, no, you have to see like alpha 10 plus alpha 11. So alpha 6 is equal to, whether you have to see alpha 10 into alpha 11. So alpha 10 is equal to alpha 10 and alpha 11. Alpha 10 is equal to, so that is equal to addition is 21, है ना, 21. So that is equal to alpha 15 into alpha 6. That is equal to alpha 15 into alpha 6. So this is nothing but alpha 6 is equal to alpha 6. So you got that alpha 10 into alpha 11 is nothing but alpha 6. Alpha 10 into alpha 11, you have to add first, 10 plus 11 is 21. Then you have to express in terms of 15. So 15 into 6, 15 is 1. So alpha 6 is equal to alpha 10 into alpha 11. So you have the equation by x is equal to 1 plus alpha 14x plus alpha 6x square. So you have expressed alpha 6 as alpha 10 into alpha 11, such that alpha 10 plus alpha 11 is equal to alpha 14. So for that you have to first see alpha 14. What we have done, we first saw alpha 14. So we have seen alpha 14 and expressed it in terms of and seen whose additions in this table comes to be alpha 14. We have seen that alpha 10 and alpha 11's addition is equal to alpha 14. And similarly, we have seen whether alpha 10 into alpha 11 is equal to alpha 6. So we got that alpha 10 into alpha 11 is equal to alpha 6. So this is trial and error. You have to see from the table. So then after that, you got this as alpha 6 is expressed as alpha 10 into alpha 11, whose addition alpha 10 plus alpha 11 is equal to alpha 14. So you have to write it as lambda x is equal to 1 plus alpha 10x plus alpha 11x. So here the same thing is written. So lambda x is equal to, instead of 1 plus alpha 14x plus alpha 6x square, you can write it as 1 plus 10 alpha 10x plus alpha 11x. After that, you have to take this as x10, this is x10, and this is x11. So ex is x11, alpha, instead of alpha 11 write x11, and instead of x10 alpha 10 you have to write x10. Then cx is, you have to add ex, this ex into yx, you will get cx. So yx is this one up to x4 5 7 x4 5 7 9, then this 10 11 12. So this is your cx. So this is somewhat lengthy problems. You see in your university exam how these problems appears. So this is it for this video. So somewhat difficulties finding the errors of this polynomial, but if you practice 2 or 3 examples, you will understand how to find the roots. You have to see the table, and accordingly for this you have to find the addition. Alpha 14's additions you have to find, and accordingly express it in terms of 2 multiplications of alpha 6. So this is it for this video. We will see problem number 3 in BCH decoding in next video.